In this video, we're going to continue on with the kinematics problem solving and focus on the actual solving of the linear accelerated motion problems. So just to reiterate, we have three equations that come from the formula chart, and each one of these equations is missing one of the variables. There are technically two other equations, but they are not given to you on the formula chart, so we're going to focus on problem solving just using these three. Now, another thing you have to know about these equations is that they are only valid for constant acceleration problems. If you have a changing acceleration, you cannot use these equations. Fortunately, in AP Physics 1, we are only going to deal with constant acceleration problems. Changing acceleration is a calculus problem, which is dealt with in AP Physics C. So, to solve accelerated motion problems, we have a step-by-step process that we're going to follow. First, you need to make your well-labeled diagram of the situation. That's going to be your motion map. Next, you're going to list all 5 kinematics variables. Then you're going to identify your knowns and unknowns. You're going to identify everything that you are given in the problem and what it is you're looking for. And the last variable is going to be something called a who cares variable. It's the variable that the problem doesn't even address. And so you need the equation that also does not contain that variable. Step 4 is you're going to use that variable, that who cares variable, to determine which equation you need to solve the problem. Then, manipulate the equation without numbers. Yes, you have to practice this. When the AP Physics test asks questions, they rarely give you numbers. It's almost always just giving you variables. So you have to practice the skill of manipulating these equations. If you're having trouble with it, please ask for help. Last, you finally get to substitute in numbers and solve for an answer. Your last step is to write your answer with units. Yes, you must have units. If you don't have units, you may not get credit. I also suggest that you put a box around your answer to make it easily discoverable. If you're doing a free response question, you want to make sure that it's easy for the reader to find your answer. Don't make them hunt for it. They have a very short amount of time to grade these questions, and if they have to hunt around, you're less likely to get credit. All right, so we're just going to start straight into a couple of examples. So the first example, we have a car that slows from a speed of 30 meters per second to a stop over a distance of 200 meters. And we want to know what was the acceleration of the car. So we're going to draw a picture first, and we know that it's slowing down. So here's our picture. We're going to start with our car moving at a certain velocity, slower velocity, even slower, and then come to a stop. To the right is going to be my positive direction, and the left is my negative direction. Now, if my velocity is in the positive direction, if it's slowing down, that means my acceleration is in the opposite direction. So it has to be in the negative direction. So if I'm solving for acceleration, I had better get a negative answer, or there is something wrong. So this is telling me something about what my answer is going to look like. My next step is I am going to list my variables. So I have my initial velocity, my final velocity, my displacement, acceleration, and time. And again, get used to writing these in the same order every time. It'll just make it easier for you in the long run. Now I need to identify the numbers, or what do I know from the problem. So the car slows from a speed of 30 meters per second. So that's where it started, at 30 meters per second. And it comes to a stop. A stop, at rest, all of those indicate a velocity of 0. So I'm ending with a velocity of 0 meters per second. It says over a distance of 200 meters. Well, that's my displacement in this problem. Then we want to know what was the acceleration of the car. So this is what we're looking for. That means time is my who cares variable. Time is the variable that the problem doesn't even mention, And so I have to choose the equation that does not include time. So looking at my list of equations, the one that does not include time is this one. That's the equation I need to solve this problem. So I'm going to go ahead and write it. My final velocity squared equals my initial velocity squared plus 2a delta x. So my next step is going to be to solve for my missing variable, or the variable I'm looking for. In this case, acceleration. So the first thing I have to do is isolate the term that contains acceleration. To do that, I'm going to subtract the initial velocity squared from both sides, rewrite the equation. I have final velocity squared minus the initial velocity squared is equal to 2a delta x. Now I need to isolate my variable. And the variable is being multiplied by 2, so I'm going to divide by 2. It's being multiplied by delta x, so I'm going to divide by delta x. Cancels, cancels. And what I do to one side, I have to do to the other side. And I'm left with the acceleration is equal to the final velocity squared minus the initial velocity squared divided by 2 delta x. So there's my equation manipulated for the variable I'm looking for. My next step is to plug in my numbers. So acceleration is equal to my final velocity, which is 0, minus my initial velocity squared. Yes, this technically is squared, but it's 0 squared is 0, divided by 2 times 200 meters. So this is going to be negative 900 meters squared per second squared divided by 400 meters. We're going to cancel a meter, and we're going to end up with negative 2.25 meters per second squared. And there's my answer. So my acceleration did come up with a negative number, or a negative sign, just like I predicted here in my picture. So then the second question down here is, how long did it take the car to stop? So now I'm looking for time. Well, now I can use any of the equations that have time in it. So now this is the only equation that I can't use. I can use either of these equations to solve this problem. Generally, we often use this one just because it's the easiest to manipulate. So my final velocity is equal to the initial velocity plus acceleration times time. So move the initial velocity to the other side. Divide by acceleration. That's going to be my time. So to plug in numbers, my final velocity is 30. My final velocity is 0 minus 30 divided by my acceleration, negative 2.25 meters per second squared. That's going to give me my time, which is equal to 13.3 seconds. Now notice time is positive. The two negative signs are going to cancel each other out. You really should always get a positive time, or there's something wrong with your math. All right, so now let's look at something that's a little bit more difficult. We're going to start the same process. We have a car that starts from rest and accelerates to a velocity of 15 meters per second. So this is speeding up. So to draw our picture, we start at rest, a little bit faster. We're going to start getting bigger and bigger distances, faster speeds. And right to the is positive, left is negative. These are my velocity vectors, and since it's speeding up, my acceleration and velocity should be in the same direction, and that is a positive acceleration. So there's my picture. Now I'm going to list my variables. Initial velocity, final velocity, displacement, acceleration, and time. There's my variables. So I know I'm going from rest. My initial velocity is 0 to a velocity of 15 meters per second, final velocity, in 5 seconds. That's time. And we want to know how far did the car travel during this time. So our who cares variable is going to be acceleration. We need the equation that does not contain acceleration. Well, if we look down here, we have a problem. All of those equations contain acceleration. So we can't use any of them to solve this problem. But what we can do is, instead of solving for our displacement first, let's solve for our acceleration, which means our displacement is now our who cares variable. So we can solve for acceleration using the equation that does not contain displacement. And this is also the next question. So we can solve using final velocity is equal to the initial velocity plus acceleration times time. Solving it for acceleration, we can plug in our numbers. And we have an acceleration of 3 meters per second per second. And this is a positive acceleration, which does fit with our picture. So now we know our acceleration is 3 meters per second squared. Now I have enough information to solve for my displacement. Now I can use either of these equations that have displacement. Generally, I'm going to use this one because it's already solved for delta x, and I don't have to manipulate it. So delta x equals v naught t plus 1/2 a t squared. My initial velocity is 0, so this whole term is 0. So delta x is equal to 1/2 times 3 times 5 seconds squared, which means my seconds are all going to cancel. And I get 37.5 meters. So now you have a problem set that has 6 different problems, and you're going to practice this. You're going to be using all 3 of these equations down here. Ask questions if you need any help.